Okay, now this is the next part. So this time here, let's go deeper into moments. So now let's talk about the first thing. Moments is a vector. What does vector means? It means that it is a physical quantity with magnitude and direction. Okay, magnitude and direction. So both magnitude and direction here. So what is a physical quantity? A physical quantity is just something that you can measure. Okay, now what's a vector? A vector is a physical quantity with magnitude and direction. So since this is a turning motion, the direction will either be clockwise or anti-clockwise. So if it rotates in a clockwise motion, then this is a clockwise moment. So clockwise moment. If it rotates anti-clockwise, this is known as the anti-clockwise moment. Okay, so there's some animation here. Let's take a look. So with regards to the animation, okay, let's click. Okay, you can see here. This is the beam, the pivot is here, this is the force applied. So apply a force, you can see that the beam moves in a clockwise motion. So clockwise. Now as for this one, over here you can see there's a force applied here. Okay, when it pushes it up, the beam turns in a anti-clockwise motion. So this is the anti-clockwise moment. Okay, nice animation there. Okay, now, so take note, moments is a vector, so there's two different directions. Okay, we can measure it and then we can talk about direction being clockwise or anti-clockwise. Whenever we talk about moments, we must state the direction that it has, clockwise or anti-clockwise, because it is a turning motion. A turning motion. So just take note of this. So now, okay, now we move deeper into the formula here. Okay, to use the turning effect formula, which is, what is it? It's actually moments of a force equals to force multiplied by distance. This distance is the perpendicular distance. Of the force from the pivot. Between the force and the pivot. Okay, so now let's use this formula. Checkpoint 1. D is the perpendicular distance. So which is the correct perpendicular distance from the door handle to the hinge? So this is the door handle, the hinges are here. Okay, the hinges, let's extend a bit more. So you can see it's A, B or C. Where is the perpendicular distance? The hinge is here, the pivot. This is the perpendicular distance. Can you see? Because it forms a 90 degrees. So this is the perpendicular distance. So moment force times distance. The distance must always be the perpendicular distance. Checkpoint 2. Okay, this is the second thing here. So first one we talk about perpendicular distance. Second thing is we must make sure that the quantity is in SI units. So what's the units for moments? This will be in Newton meter. For force, it must be in Newton. For distance, it must be in meters. So take note, force is in Newton, perpendicular distance is in meters. They must be in their SI unit. So this is very important. Otherwise, your moments will no longer be Newton meter. They will be something different. So please take note of this. Okay, so 2 checkpoints that we have gone through. We talk about vector being, moments being a vector, have both magnitude and direction. 2 different directions that has clockwise and anti-clockwise. Then we went on to look at the formulas, how we can use it, what to take note of. Always taking note that D is the perpendicular distance. And the second checkpoint is that all of the units must be in SI units. For force is in Newton, for perpendicular distance is in meters. So that's it for this part.